Burying a splice box in a ceiling covered with sheetrock is a violation of the National Electrical Code, specifically Article 314.20, which states that conductors and equipment within raceways, boxes, cabinets, auxiliary gutters, enclosures, or manholes shall be accessible for examination and maintenance. In the event of a house fire, the employee, the foreman, and the contractor could all be held liable. The employee, even when following instructions, has a duty to follow the National Electrical Code and to refuse to perform any work that would violate the code. By burying the splice box, the employee violated the code and could be held liable for any resulting damage. The foreman has a supervisory responsibility to ensure that all electrical work is performed according to the code. By directing the employee to bury the splice box, the foreman violated the code and could be held liable for any resulting damage. The contractor is ultimately responsible for the electrical work performed on the house. By failing to ensure that the splice box was installed in accordance with the code, the contractor could be held liable for any resulting damage. Now, let's consider potential defenses. The employee, foreman, and contractor may attempt to defend themselves. Firstly, they might argue they were not aware that burying the splice box violated the code. Secondly, they might claim they relied on the judgment of the electrical inspector who approved the installation. Thirdly, they might assert the fire was caused by another factor, not by the buried splice box. However, these defenses are unlikely to be successful if it is demonstrated that the employee, foreman, and contractor were negligent in their conduct. Accessibility is a cornerstone principle within the National Electrical Code, aimed at ensuring the safety and maintainability of electrical systems. It mandates that electrical components, including splice boxes, must be readily accessible for inspection, maintenance, and repairs without requiring extensive demolition or disassembly of building structures. The rationale behind this requirement is multifaceted. Firstly, it facilitates routine inspections, enabling qualified personnel to identify potential hazards such as loose connections, corroded wiring, or signs of overheating before they escalate into more serious problems. Secondly, it simplifies troubleshooting and repairs, allowing electricians to quickly locate and address faults or malfunctions, minimizing downtime and inconvenience. Thirdly, it enhances safety by providing easy access for emergency responders in the event of a fire or other electrical incident, enabling them to isolate power sources and mitigate risks. The National Electrical Code provides specific guidelines regarding the accessibility of electrical equipment. These guidelines typically address factors such as the location of equipment, the presence of obstructions, and the need for clear working spaces. For instance, the National Electrical Code may require that electrical panels be installed in readily accessible locations free from obstructions such as furniture or storage items, and with adequate clearance to allow for safe operation and maintenance. Similarly, the National Electrical Code may specify that splice boxes and junction boxes be installed with removable covers or access panels, enabling easy access to the wiring connections inside. The implications of violating accessibility requirements can be significant. Firstly, it can increase the risk of electrical hazards such as fires, shocks, and equipment failures. Secondly, it can complicate maintenance and repairs, leading to delays, high costs, and potential safety risks for electricians. Thirdly, it can expose building owners and contractors to legal liability in the event of an accident or injury. In addition to the National Electrical Code, other regulations and standards may also address the accessibility of electrical equipment. These may include local building codes, industry best practices, and manufacturers' installation instructions. Compliance with these requirements is essential to ensure the safety and reliability of electrical systems and to minimize the risk of accidents, injuries, and property damage. Therefore, when installing electrical systems, it is imperative to prioritize accessibility. This involves careful planning, proper selection of equipment, and adherence to all applicable codes and standards. It also requires ongoing maintenance and inspections to ensure that equipment remains accessible and in good working condition throughout its lifespan. Electrical safety is a shared responsibility, requiring the cooperation of electricians, contractors, building owners, and regulatory authorities. By working together to promote accessibility and compliance with electrical codes, we can create safer and more reliable electrical systems for everyone. The concept of negligence plays a crucial role in determining liability in cases involving electrical code violations. Negligence, in legal terms, refers to a failure to exercise the care that a reasonably prudent person would exercise under similar circumstances. In the context of electrical work, negligence can arise from various acts or omissions, such as improper installation, inadequate maintenance, or failure to adhere to safety standards. To establish negligence, several elements must be proven. Firstly, there must be a duty of care owed by the defendant to the plaintiff. In the case of electrical work, this duty of care typically arises from the contractual relationship between the electrician or contractor and the property owner or occupant. Secondly, there must be a breach of that duty of care. This occurs when the defendant's conduct falls below the standard of care expected of a reasonably prudent person in the same situation. For example, if an electrician fails to properly ground an electrical outlet, resulting in a shock hazard, this could constitute a breach of duty of care. Thirdly, there must be a causal link between the breach of duty and the damages suffered by the plaintiff. In other words, the plaintiff must demonstrate that the defendant's negligence was a direct and proximate cause of their injuries or losses. For instance, if a fire is caused by faulty wiring installed by an electrician, and a homeowner suffers property damage as a result, this could establish a causal link. Fourthly, the plaintiff must have suffered actual damages as a result of the defendant's negligence. These damages can include medical expenses, lost wages, property damage, and pain and suffering. In cases involving electrical code violations, negligence can be established by demonstrating that the electrician or contractor failed to comply with the applicable codes and standards. The National Electrical Code, along with other relevant regulations, sets forth specific requirements for electrical installations, maintenance, and safety. Failure to adhere to these requirements can be considered evidence of negligence. For example, if an electrician buries the splice box in a wall without providing proper access, in violation of the National Electrical Code, and this leads to a fire, the electrician could be found negligent. It is important to note that even if an electrical installation meets the minimum requirements of the National Electrical Code, negligence can still be established if the electrician or contractor failed to exercise reasonable care in performing the work. For instance, if an electrician uses substandard materials or performs shoddy workmanship, even if the installation technically complies with the National Electrical Code, this could still be considered negligent if it leads to an accident or injury. The concept of foreseeability is also relevant in determining negligence. Foreseeability refers to the ability to anticipate the potential consequences of one's actions or omissions. If a reasonably prudent person would have foreseen that a particular action or omission could lead to harm, then the defendant may be held liable for negligence. In the context of electrical work, foreseeability might involve recognizing the potential for electrical shock, fire, or equipment failure resulting from improper installation or maintenance. For example, if an electrician fails to properly insulate wiring in a damp location and this leads to an electrical shock, the electrician could be held liable for negligence because a reasonably prudent person would have foreseen the potential for harm. In summary, negligence is a key factor in determining liability in cases involving electrical code violations. To establish negligence, it must be proven that the defendant owed a duty of care, breached that duty, caused damages to the plaintiff, and that the damages were foreseeable. Compliance with the National Electrical Code and other relevant regulations is essential to avoid negligence, but it is not always sufficient. Electricians and contractors must also exercise reasonable care and skill in performing their work to protect the safety of others. The role of electrical inspections in ensuring code compliance and safety cannot be overstated. Electrical inspections serve as a critical safeguard against faulty installations, substandard materials, and violations of electrical codes. These inspections are typically conducted by qualified electrical inspectors who are trained to identify potential hazards and ensure that electrical systems meet the required standards. The primary purpose of electrical inspections is to protect the safety of people and property. By verifying that electrical installations comply with the National Electrical Code and other relevant regulations, inspectors help to prevent electrical shocks, fires, and other hazards. They also ensure that electrical systems are properly grounded, protected from overcurrents, and installed in accordance with manufacturer's instructions. Electrical inspections are typically required at various stages of the construction process, including rough-in when the wiring is installed, but before it is covered by walls or ceilings, service when the electrical service is connected to the building, and final when all electrical work is completed. These inspections provide an opportunity to identify and correct any deficiencies before the electrical system is energized and put into service. During an electrical inspection, the inspector will typically examine a wide range of electrical components and systems, including wiring, outlets, switches, circuit breakers, panels, grounding systems, and lighting fixtures. They will also check for compliance with the National Electrical Code and other applicable regulations, such as local building codes and energy efficiency standards. If the inspector finds any violations or deficiencies, they will typically issue a notice of violation to the contractor or property owner, specifying the corrective actions that must be taken. The contractor or property owner is then responsible for making the necessary repairs or modifications and scheduling a re-inspection to verify that the work has been completed properly. In some cases, electrical inspections may also be required for existing buildings, particularly when renovations or alterations are being performed. These inspections help to ensure that the electrical systems in older buildings are safe and up to code. The qualifications and training of electrical inspectors are essential to ensure the effectiveness of the inspection process. Electrical inspectors typically have extensive experience in the electrical trade and must pass a certification exam to demonstrate their knowledge of electrical codes and standards. They must also stay up to date on the latest changes to the National Electrical Code and other regulations. The benefits of electrical inspections extend beyond safety. Properly installed and maintained electrical systems are more reliable, energy efficient, and cost-effective. They also help to protect property values and prevent costly repairs. In addition to mandatory electrical inspections, many homeowners and business owners choose to have voluntary electrical inspections performed on their properties. These inspections can provide peace of mind and help to identify potential problems before they become serious. In summary, electrical inspections are a critical component of electrical safety. By ensuring that electrical systems comply with the National Electrical Code and other regulations, inspections help to protect people and property from electrical hazards. They also promote energy efficiency, reliability, and cost-effectiveness. Therefore, it is essential to have electrical inspections performed by qualified inspectors at all stages of the construction process and for existing buildings as needed. Let's consider the specific requirements for splice box installations according to the National Electrical Code. The National Electrical Code provides detailed guidelines for the installation of splice boxes, also known as junction boxes, to ensure the safety and reliability of electrical connections. These requirements cover various aspects of splice box installations, including location, accessibility, wiring methods, and grounding. Firstly, the National Electrical Code specifies where splice boxes are permitted to be installed. Generally, splice boxes are allowed in accessible locations such as attics, crawl spaces, and above suspended ceilings. However, they are not permitted to be buried in walls or ceilings without providing access. This is to ensure that the connections inside the box can be inspected and maintained. Secondly, accessibility is a key requirement for splice box installations. The National Electrical Code mandates that splice boxes must be readily accessible without requiring the removal of any part of the building structure. This means that the box must be located in a place where it can be easily reached and opened for inspection, maintenance, or repairs. The National Electrical Code may also specify minimum clearances around splice boxes to provide adequate working space for electricians. Thirdly, the National Electrical Code outlines the permissible wiring methods for connecting conductors inside splice boxes. All wiring connections must be made in accordance with the National Electrical Code requirements, using approved methods such as wire connectors, soldering, or crimping. The conductors must be properly sized for the circuit and insulated to prevent shorts or ground faults. The National Electrical Code also prohibits the use of open splices or exposed wires inside splice boxes. Fourthly, grounding is a critical aspect of splice box installations. The National Electrical Code requires that all metal splice boxes be properly grounded to provide a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding conductor must be sized according to the National Electrical Code tables and securely connected to the box using approved methods such as grounding screws or lugs. Fifthly, the National Electrical Code may specify additional requirements for splice box installations in certain locations, such as wet or damp environments. In these cases, the splice box must be listed for use in wet locations and installed in a manner that prevents moisture from entering the box. The National Electrical Code may also require the use of weatherproof fittings and seals to protect the wiring connections. In addition to these general requirements, the National Electrical Code may also address specific issues such as the number of conductors permitted in a splice box, the size and type of wire connectors, and the use of cable clamps to secure the wiring. Compliance with these requirements is essential to ensure the safety and reliability of splice box installations. Failure to follow the National Electrical Code guidelines can lead to electrical hazards such as fires, shocks, and equipment failures. Therefore, it is important for electricians and contractors to be familiar with the National Electrical Code requirements for splice box installations and to adhere to them carefully. Electrical codes and standards, like the National Electrical Code, are not static documents. They are constantly evolving to keep pace with technological advancements, new safety concerns, and changes in industry practices. The process of updating and revising electrical codes and standards is a collaborative effort involving various stakeholders, including electrical engineers, contractors, manufacturers, inspectors, and regulatory agencies. The National Electrical Code, for example, is revised every 3 years by the National Fire Protection Association, a non-profit organization that develops and publishes codes and standards for fire prevention and electrical safety. The process of revising the National Electrical Code begins with the submission of proposals for changes to the code. These proposals can be submitted by anyone, including individuals, companies, and organizations. The proposals are then reviewed by the National Electrical Code technical committees, which are composed of experts in various areas of electrical safety. The technical committees evaluate the proposals based on technical merit, safety considerations, and cost effectiveness. They may also conduct research and testing to gather additional information. After reviewing the proposals, the technical committees develop recommendations for changes to the National Electrical Code. These recommendations are then published for public comment. The public comment period provides an opportunity for interested parties to review the proposed changes and provide feedback. The technical committees then review the public comments and make any necessary revisions to their recommendations. The final recommendations are then submitted to the National Fire Protection Association Standards Council for approval. The Standards Council is responsible for ensuring that the National Electrical Code meets the National Fire Protection Association standards for quality and consensus. Once the National Electrical Code is approved by the Standards Council, it is published and becomes the new edition of the code. The new edition of the National Electrical Code is then adopted by state and local jurisdictions, which may make some modifications to the code to suit their local needs. The process of updating and revising electrical codes and standards is ongoing. The National Fire Protection Association is constantly working to improve the National Electrical Code and to address new safety concerns. As technology advances and new electrical products and systems are developed, the National Electrical Code must be updated to ensure that they are installed and used safely. Staying current with the latest changes to electrical codes and standards is essential for electricians, contractors, and other electrical professionals. Failure to comply with the latest codes and standards can lead to safety hazards, code violations, and legal liability. Therefore, it is important to participate in continuing education and training programs to stay informed about the latest changes to electrical codes and standards. The role of documentation in electrical work is critical for ensuring safety, accuracy, and compliance with codes and standards. Proper documentation provides a record of the electrical system's design, installation, and maintenance, which can be invaluable for troubleshooting, repairs, and future modifications. There are several types of documentation that are commonly used in electrical work. Firstly, electrical drawings, also known as blueprints or schematics, provide a visual representation of the electrical system's layout, wiring, and components. Electrical drawings typically include information such as the location of outlets, switches, lighting fixtures, panels, and other electrical equipment. They also show the wiring connections between these components, including the wire sizes, conduit types, and grounding methods. Secondly, load calculations are used to determine the electrical demand of a building or facility. Load calculations take into account the power requirements of all electrical equipment and appliances, as well as factors such as occupancy, square footage, and climate. Load calculations are essential for sizing the electrical service, panels, and conductors to ensure that they can safely handle the expected electrical load. Thirdly, panel schedules provide a detailed listing of the circuits in an electrical panel, including the circuit number, the type of load served, the breaker size, and the wire size. Panel schedules are used to identify and locate circuits quickly and easily, which is essential for troubleshooting and repairs. Fourthly, equipment specifications provide detailed information about the electrical equipment used in the system, such as transformers, generators, motors, and control systems. Equipment specifications typically include information such as the manufacturer, model number, voltage, current, power rating, and efficiency. Fifthly, test reports document the results of electrical testing and inspections. Test reports typically include information such as the date of the test, the type of test performed, the equipment tested, and the results of the test. Test reports are used to verify that the electrical system is operating properly and safely. Sixthly, maintenance records document the maintenance and repairs performed in the electrical system. Maintenance records typically include information such as the date of the maintenance, the type of maintenance performed, the parts replaced, and the name of the person who performed the maintenance. Proper documentation is essential for ensuring the safety and reliability of electrical systems. It also helps to prevent errors, reduce downtime, and improve communication between electricians, contractors, and building owners. In addition to these benefits, proper documentation is also required by many electrical codes and standards. The National Electrical Code, for example, requires that electrical drawings, load calculations, and panel schedules be maintained for all electrical installations. Therefore, it is important for electricians and contractors to be familiar with the documentation requirements of the National Electrical Code and to comply with them carefully. The importance of continuing education for electrical professionals cannot be overemphasized. The electrical industry is constantly evolving, with new technologies, materials, and codes being introduced on a regular basis. To remain competent and effective, electrical professionals must engage in ongoing learning and professional development. There are several benefits to continuing education for electrical professionals. Firstly, it helps them to stay current with the latest changes to electrical codes and standards. The National Electrical Code, for example, is revised every 3 years, and it is essential for electrical professionals to be aware of the latest changes to ensure that they are compliant with the law and providing safe and reliable electrical services. Secondly, it enables them to learn about new technologies and materials. The electrical industry is constantly developing new and improved products and systems, and electrical professionals must be able to install, maintain, and troubleshoot these technologies effectively. Thirdly, it enhances their skills and knowledge. Continuing education can help electrical professionals to improve their technical skills, problem-solving abilities, and communication skills. This can lead to increased job satisfaction, career advancement, and higher earning potential. Fourthly, it helps them to maintain their licenses and certifications. Many states and local jurisdictions require electrical professionals to complete a certain number of continuing education hours in order to renew their licenses and certifications. This ensures that electrical professionals are staying up to date on the latest industry standards and best practices. There are several ways for electrical professionals to obtain continuing education. Firstly, they can attend workshops and seminars offered by trade associations, technical schools, and manufacturers. These workshops and seminars typically cover a wide range of topics such as electrical codes, safety practices, new technologies, and business management. Secondly, they can take online courses. Online courses offer a convenient and flexible way for electrical professionals to learn at their own pace and on their own schedule. There are many reputable online providers that offer high-quality electrical continuing education courses. Thirdly, they can attend industry conferences and trade shows. These events provide an opportunity for electrical professionals to network with their peers, learn about new products and services, and attend educational sessions. Fourthly, they can read trade publications and technical articles. Trade publications and technical articles provide valuable information about the latest trends, technologies, and best practices in the electrical industry. In addition to these formal methods of continuing education, electrical professionals can also learn through on-the-job training and mentoring. Working alongside experienced electricians and engineers can provide valuable hands-on experience and insights. In summary, continuing education is essential for electrical professionals to stay current with the latest changes to codes, technologies, and best practices. It helps them to enhance their skills and knowledge, maintain their licenses and certifications, and provide safe and reliable electrical services. Therefore, it is important for electrical professionals to make continuing education a priority throughout their careers.